Okay, I hope you all attempted this problem on your own. Now let's look at it together. So triangle ABC is a right triangle. Which is the best approximation, and that word approximation means estimate, right? So which is the best approximation for the measure of angle C? Okay, so now we're actually looking for the measure of the angle because it says measure of angle C, not just a ratio. What's interesting about this problem is that they give you these three different trig ratios for these angle measurements. So I don't know if they would disable the calculator on this problem on the EOC or not, but what we're going to do is we're going to do it both ways. We're going to use this, and we're also going to use the calculator. All right, so we automatically know, first step, label the triangle. Since we're looking for the best estimate of angle C, we know that C is our theta. All right, our hypotenuse is the longest side across from the right angle. Our opposite side is across from the theta, which makes this our adjacent side. All right, so I'm going to start off by doing this problem using these three ratios, right? All right, so basically sine of 67.4 degrees is equal to this. Cosine of 22.6 is equal to this, and tangent of 42.7 is equal to this. Well, these are some sort of fractions, right? So the different possibilities we have are these ratios that I just wrote down for you. So 12 over 13 is a possibility. That would be our cosine, adjacent over hypotenuse, right? 5 over 12 would be our tangent, opposite over adjacent, and 5 over 13 would be our sine, opposite over hypotenuse. So basically what I did was I just found all of these different possible combinations of sides, and then I just went to my calculator on my phone, and I got an approximation for what each of these are. All right, and I rounded it to 4 decimal places. That's why I did the equal sign is squiggly, because it's an approximation, right? Okay, so looking at these, now that I've done that, what do you notice about my possibilities and what they have written for us right here? All of these are equal to 0.923. Same as this, right? So we used 12 over 13 to get 0.923. The side that's the length of 12 is the adjacent side. And the hypotenuse is the 13. So we're using cosine, right? Our only option here for cosine is our middle number. So cosine of 22.6 gives us an approximation of 0.923. That means theta must be approximately equal to 22.6, because that's the only one that works. All right, now I'm going to also do it the other way, that if we just ignored these right here and use our calculator, we could do this. So I have all three sides of this right triangle, so I can literally pick any sort of trig ratio and use inverse trig. I'll do all three since we have time, right? All right, so let's do inverse trig of sine. So what I would do is sine of theta is equal to opposite over hypotenuse, 5 over 13. All right, now to do that in the calculator, you're going to go to your Desmos app. First, you're going to make sure it's in degrees like I asked you to do. I think it defaults back every time you get out of it. You're going to click on functions and inverse sine because we're using the inverse. You're going to put 5 divided by 13, and that's going to give us a theta of 22.62 degrees, and which is what we found out right there. All right, let's use cosine now and see if we get the same answer. Cosine of theta would be 12 over 13. So again, I'm just going to use Desmos, and I'm going to hit functions, inverse cosine, make sure it has that -1 exponent, and do 12 divided by 13. This again gives us 22.62 degrees. Spoiler, what do we think tangent's going to be? So tangent of theta would be opposite over adjacent, so 5 over 12. So we'll go down again and we'll do functions, tangent, 5 divided by 12, 22.62. All right, so that was 4 different ways to do this problem. You can use the ratios they give you, or you can use any of the 3 trig ratios because they gave us all 3 sides. All right, nice job. We're on the last page now, and what I want you to do is go ahead, pause the video, and attempt this on your own. I noticed that there's no picture, so I suggest you draw a picture and label that triangle. So go ahead and pause the video and try this next problem on your own. Once you are finished, come back and we'll check your work. Okay, as you can see, I've been working on my drawings at home. That's how I spend my free time, just drawing right triangles and taking online handwriting classes to make myself better for you guys. All right, so in right triangle ABC, angle A and angle B are complementary angles. So complementary, we know they sum to 90. And we know that those 2 angles must be the non-right angles, right? So A, B, and C must be the right angle. All right, so if they're complements and they tell us the word complementary, we should automatically think of our complement theorem, right? Sine of A is equal to cosine of B. Cosine of A is equal to sine of B. So they tell us the value of cosine A. They say cosine of A is 5 over 13. What is the value of sine of B? Our complement theorem tells us they're equal. So cosine of A and sine of B are exactly the same thing, 5 over 13. So your answer here is A. I'm going to go ahead and label the triangle and we'll prove out why the complement theorem works. All right, so looking at this, the value of cosine of A is 5 over 13. All right, so if I made A my theta, this would be my hypotenuse. Line CB would be my opposite because it's across from theta. Let me try and focus. I don't know why I got out of focus. Which would make line AC the adjacent. All right, so if cosine of A is 5 over 13, we know that cosine is adjacent over hypotenuse. So our adjacent side must be 5. Adjacent side is 5. Our hypotenuse is 13. All right, so looking at this, if I were to change my angle of perspective and now instead make B my theta, we already said that this side right here was 5 and this side was 13 because of the cosine relationship, right? If I now make B my theta instead, that's supposed to be a theta, my hypotenuse wouldn't change, but my side AC would now be the opposite side, right? So my sine of B would be opposite over hypotenuse, so sine of B would be 5 over 13. Which is what we already proved with the complement theorem, right? All right, nice job with that. Only got 2 more left, so go ahead and pause the video, and I want you to attempt this next problem on your own. Come back, and we will do it together. Okay, so in right triangle HJK, J is a right angle, and tangent of H equals 1. What statement about triangle HJK must be true? Okay, so let's go ahead and draw a picture so we can see things clearly, and then we can eliminate some answers and see which one is the true answer choice. All right, so they tell us that J is the right angle, so J must be here. All right, so H and K are my other 2 angles. All right, it tells you tangent of H is 1. So remember, tangent of theta is opposite over adjacent. So if tangent of H is 1, your opposite and your adjacent are going to be exactly the same because a number over itself is equal to 1. And opposite and adjacent are both legs. Remember, hypotenuse is the only thing that's different. So let's go ahead and make up some numbers and we'll fill in the rest of the triangle and we'll see which one of these is true. So if the opposite side and the adjacent side, the 2 legs must be the same, let's go ahead and just call them 2. So HJ must be 2 and JK must be 2. Again, you can use another number as long as these sides are equal, right? Tangent of H is equal to 1, which is telling us that the opposite and the adjacent are exactly the same, right? 2 divided by 2 would simplify to 1. All right, now I can fill in the hypotenuse using the Pythagorean theorem. So I'm missing a hypotenuse this time, so I would set it up as 2 squared plus 2 squared equals c squared. Well, we know 2 times 2 is 4. So 4 plus 4 equals c squared, and 4 plus 4 is 8. Last step to get the hypotenuse is I would take the square root of both sides to undo this exponent. So that would mean that our hypotenuse in this situation is square root of 8. Remember, we just made up numbers to see what would be true, right? So you could have used different numbers. You could have used 1 and 1, 3 and 3, whatever would make sure that the two legs are identical, which would also make it an isosceles right triangle. Okay, so let's take a look at these answer choices and see what would be true. So all of them involve H as the angle of perspective for the most part, right? So I'm going to say H is my theta, which would make square root of 8 the hypotenuse, this side my opposite, and this side my adjacent. So it says sine of H is equal to 1 over 2. So sine would be opposite over hypotenuse, right? 2 over square root of 8, does that simplify to 1 over 2? I don't think so. I will confirm on the calculator for you. You could also do this on your Desmos app. It does not, right? It's well over 1/2. So A cannot be true. All right, B, sine of H is equal to 1. Well, we already know that's not true because we just did sine of H, right? 2 over square root of 8 does not equal 1. All right, let's see if sine of H is equal to cosine of H. So we already found sine of H. What would cosine of H be? Cosine would be adjacent over hypotenuse, right? Adjacent is 2, hypotenuse is square root of 8. It's exactly the same. So sine of H and cosine of H are exactly the same. And that makes sense because it's an isosceles right triangle, so both of these legs are equal. So C is your correct answer. All right, nice work. Last question. So go ahead, pause the video, attempt this on your own. If you're not attempting it on your own, you're not really making mistakes, and that's how you learn in math. Don't be afraid to make an error. That's how we remember things and how we go through the learning process. So please pause the video and attempt the last question on your own. Come back when you're done. All right, last question. A hot air balloon is 1,200 feet above the ground. The angle of depression from the basket of the hot air balloon to the base is 54 degrees. All right, automatically I know that the angle of depression is equal to the angle of elevation because they're alternate interior. So this 54 degrees, I can also put this as 54 degrees, right? They're alternate interior. So now I have an interior angle of this triangle, which will help me in the future. All right, so if that's 54, then this is 54. What equation can be used to find the distance, d, in feet from the basket of the hot air balloon to the base of the monument? So we're looking for this distance right here. All right, so the first thing we need to do is label the triangle. My interior angle that I have is my theta, which would make d my hypotenuse. Across would be my opposite side, and the ground would represent my adjacent. All right, the two things that I would circle would be opposite and hypotenuse because I have a number and a variable next to those two sides. So now I can set up the equation, which is what the question's asking us to do. Which equation can be used? But not only are we going to set up the equation, we're also going to solve it just so we can remember how to do that. All right, so opposite and hypotenuse, I hope you are thinking sine. So sine of theta, which we know is 54, would be equal to opposite, which is 1,200, over d, opposite over hypotenuse. So this was a multiple choice question, and we took off the answer choices. This would be the correct answer choice, but we're going to take it one step further and solve it. So my variable's on the bottom, so I'm going to switch it with the trig function and say that d is equal to 1,200 divided by sine of 54. And let's plug that into Desmos really quickly because I'm running out of time. And that way you can see. Again, make sure you're in degrees. All right, 1,200 divided by function sine 54. So that is our distance right there, 1,483 feet.